Hello, I'd like to discuss my thought process on this problem. Find all possible recipes from given supplies. This is, again, a topological sort problem, and I'll be using the cons algorithm or the BFS and DAG to approach to solve this problem. So initially, we are given a supply list or array containing all the ingredients that we initially have. So we can think of like this. We go to the supermarkets or we are being provided these most basic ingredients. And see here, we want to use flour and eggs to make the dough. Dough is a recipe ingredient we will be making. And ultimately we'll make pizza. As you can see, these four basic or lower supplies, they have an degree of 0, means we can start using them. For example, start taking them. So then we can complete dough and pizza, just like course schedule. Once these two are used to make dough, dough's degree becomes 0. And now that dough can be used along with mushroom and cheese. These three can be combined or used to make pizza. Pizza will now become 3. So our result would have pizza and dough. That's what we're returning. So back to this problem, it's a little bit wordy. So my understanding that I am given 3 inputs, a recipe input, which each I is just the name of a recipe. For example, dough. For example, at I, like 0. And ingredients at this I, which means, or at 0, or means everything needed to make dough. And once we have dough, maybe dough will become a supply. Let's say will become a supply for pizza. So maybe perhaps ingredients at like 5, which is to make a pizza, has dough in there. It sounds pretty nested, but it's just basically a topological sort. You know, as dough gets made, dough then becomes a ingredient or supply to make pizza. It's just like dependency problems. Like if you want to take a course, you have to complete the basic course, move on to the intermediate course and the advanced course. The course becomes a prerequisite itself to more advanced class. And also, like when we have to install libraries, dependency problems, that just tells you you should be using topological sort. Okay, so let's get started. Here I'm using the importer library, default dict, and DAG. So for topological problem or for cons, we need to pre-process our data, which we need to build the graph, right? I need to build 2 things. So first of all, this dict, default dict, is gonna be a list. So here it's gonna be key. I have it here ready, actually, so I'll use this. So dictionary, the key is gonna be the recipe, the name of the recipe. Like for example, here, bread, right? And then it's gonna be a list of recipes or supplies. And in degree, for example, in degree of this recipe, I wanna see how many supplies are needed to make this recipe. Okay, so we're gonna use a nested for loop because the ingredient is a list of list. Okay, so for I in range length of recipe, now recipe at I is the name, for example, dough here, right? And ingredients at this I means everything needed to make the dough, right? So I need to start constructing or make the relationship. Because lower is going to be the key, I'm going to look, so basically bottom up to see who I can build. So this ingredient may be eggs. So maybe here like lower equals to egg, higher is the dough, right? So egg can be used to make the dough. So I do that. So the purpose here is to construct the adjacency list, the dictionary or the graph, and also the in degree. The recipe at I basically just the name of the recipe plus 1. After we do that, we can start making our food. Because we are given the supplies, it's something that we have or start with that we don't have to worry. They are guaranteed to have in degree of 0, means we can start using them. They are our raw materials. We can start. So I will use a deck and just pass in supplies. We are guaranteed. We are guaranteed to these have in degree of 0. Okay, and again, I will save it to result. So while my beginning materials are not empty, I'm gonna start using my materials, my supplies. So pop left, pop the first item. Now for the upstream or the recipe, like this item, what can this item make, right? So let's call it recipe. So for recipe in this item, because I'm doing a bottom up search, I'm looking upwards and see what can I made? What can be made using me? So flour, it's looking at its neighbor, which is dough. Dough can be made next, right? So that's dough's neighbor. Since this can be made, so in degree of this recipe can now be decremented, means I'm one step closer on using this recipe or on completing this recipe. Okay, now if in degree of this recipe after decrementing is 0, means this recipe is ready or can be made, or I made it. So now I can append this result recipe. And of course, the problem here says the recipe can also be used to make other recipes. So for example, now that dough is ready to go and dough gets appended to my deck, so it can now be used to make pizza. So that's what has to go back to my deck. Means the next level. When all that is done, we'll just return what can be made. Okay, recipes. I think here is that. If we submit it, time and space, I believe, is still nodes plus edges, because we are visiting each one item once in the adjacency list, the edges, and the nodes. So it's V plus E for space and time. Thank you.